Hello, everyone. Hope all of you are doing very, very well. All of you are in good health. So something about the InfoSec train. InfoSec train is in this domain since last 5 years. We have trained a lot of people, 15,000 plus people who we have trained. We have 150 plus courses that we offer training on. We have more than 100 plus corporate partnerships, and we have a healthy set of trainers that are here to upskill all the people and bridge the gap of demand and supply of cybersecurity professionals. Yeah, thank you, Kapil. So here's our endorsements, and here are our key clients, corporate clients who have entrusted us with upskilling their employees, which includes Infosys, McAfee, Microsoft, Deloitte, Oracle, Capgemini, Accenture, Cognizant, etc. So all big names, they have put their trust in upskilling their employees on InfoSec train, and yeah, that is one thing which speaks about the brand. Then we have global partnerships with Microsoft, CompTIA, ISACA, etc. to deliver the certificates and trainings. And yeah, then let's start the session. Here's the, so we have introduced this questions. So we have introduced this new thing since the last session, since the domain 2 review. We have introduced this one thing that we review questions about the session that we had discussed about previously. So this time around, I have included the questions from both first and second domain in the review itself, so that you may be able to better recall and better be able to grasp the concepts that we have discussed there. So the first question is, and how do we tackle it? I'll show you a question or two on this on one slide. In one slide at a time, there can be maximum 2 questions, either 1 or 2. I'll give you 10 seconds after I read out the questions and options for you. And after I finish reading after your 10 seconds are over, you put your answers in the chat box. So that is how we do it. So within those 10 seconds, I'll read the question for you. I'll read the options for you. And then you'll have 10 seconds to punch in your answers, put your answers in the chat. So here's our first question. And that is, Sunil and Kishore work at Trishul Technology, an industrial startup company specializing in building a diatom sphere. Currently, they have a satellite in the deepest reaches of the space, analyzing and sending back an immense amount of cosmic data. When the telemetry data comes in, Sunil has to classify it as important, useful, or negligible. To make the things a bit easier on Sunil, Kishore has volunteered to help his co-worker transfer, archive, mark, label, and back up all pertinent data to an external location. As they gain more funding and continue to work, Trishul Technology has been asked to implement proper security governance structures and rules to make sure all the spatial data is organized, valued, and available at all times. A new data classification policy also needs to be created. So according to this scenario, what would be Sunil's role after the policy has been issued? So once they bring this new data classification policy, what will be the role that Sunil be playing in the organization? So here are your options, whether Sunil be a data user, data owner, data custodian, or data processor. And your 10 seconds start now. So 10 seconds are up, guys. And yeah, so some of you are right, some of you are wrong. That's all right. That is the point. We'll discuss it out. Good that you have put your answers in. So who is a data user? We discussed last time around that anybody who is using the data, basically maybe an organization who is collecting the data at collection point, that is a data user. Or similarly, anybody who is utilizing the data for any kind of organization usage. Who is data owner? Data owner is somebody who tells you how to classify the data, what kind of control shall be put on the data, and stuff like that. So the major decision taker is data owner in this case. Who is data custodian? A data custodian's primary responsibility is to ensure that all the technical controls are in place in line with the guidelines either driven by the policy or required by the data owner. So this guy is technical. This role is technical in nature. It will ensure technical control. And data processor is somebody who is processing the data for, to convert data to usable information. You get raw data, you convert it to usable information. So in this case, what Sunil's responsibility is to classify it as important, useful, and negligible. Sunil is classifying it. Hence, Sunil is data owner. So anybody who has put B as the option, they are correct. And here's the justification. If you have any questions around this, you can pin it and we can discuss it at the end of the session. Okay, let's proceed. Here is your second question and the third one also. And the options for both of these questions will remain the same. So I'll read out the question for you. The question is, when protecting information assets, which of the following security control is most effective for data in motion? First, requiring whole disk encryption for all devices with a AES. B is implementing encryption with TLS or IPsec. That is basically a tunnel. Then C, implementing whole memory encryption with the storage of keys in CPU registers. And the fourth option is requiring the use of next-gen firewalls and or network-based intrusion prevention system. So your time starts now. You'll have 10 seconds to punch in your answers. Okay, guys, time's up. And I think everybody has punched in B only. And it is because this is data in motion. And what data in motion means is it is running on wire. So it is here somewhere. Here is your computer, here is the other computer, and the data is here somewhere. It is on wire. So when it is on wire, there shall be a tunnel which is protecting the data. Then the third one is, when protecting information assets, which of the following security controls is most effective for data at rest? So your time starts now. You guys have 10 seconds and the options remain the same. So you'll have to choose from the same options. Okay, time's up. So yeah, again, all of you are correct because it is data at rest, meaning it is sitting on secondary storage, not being loaded in the RAM. So it is either sitting in SDD or SDD, whatever, solid SSD, whatever kind of secondary storage are you using. And there you can use full disk encryption or whole disk encryption using a symmetric algorithm. AES is a symmetric algorithm. So you're using symmetric algorithm to do a full disk encryption. Yeah, that is all right. All of you have gotten it right. So congratulations, everybody. You guys are really putting some efforts. And going to the third slide, the fourth question. The IT department head is looking into purchasing a security control for a system that hosts processes owned by the sales program manager. The system is valued at 5 million. The options for cost of the control is either 2 million or from another vendor, it is at 4 million. The IT department initially chooses 4 million option, but the head of sales rejected it and asked to prepare a comparative solution and whatnot. And then finally, IT department comes to the solution, which was of 2 million, which costed 2 million. What is the role? What role is represented by the head of sale, the guy who said no to the $4 million control? Your time starts now. And your time is up. So yeah, anybody who has said business owner was correct. And that shows me that you guys are referring to the right material because most of the people have gotten it right. Why it is not a data processor? Because it is not the responsibility of data processor to say anything in the kind of controls that you're going to put. At best, it can be a data owner who can tell what kind of controls shall be put. But again, it basically, the primary roles and responsibility is to often for data owners to classify it and then put controls and whatnot. So At best, the only doubt one might have was A and C, and most of you have gotten C, and C is the right option because it is a business owner who takes the final call as to what amount of money shall be expended on any kind of control. Okay, cool. We'll proceed to the next one. So now we are going to recap the previous two sessions that we have had, and after that we'll resume on the question answer again, because I have lined up another few slides. Because how I wanted it to proceed is I'll give you a few questions, we'll brush it up, and then we'll proceed to a few more questions, as we discussed last time around that we wanted more questions to be included. So yeah, again, the basics of CISSP, it has got 8 domains, 100 to 150 questions. If you score more than 70% in first 100 questions, you need not to solve any further questions. Even if you solve 100 questions in 30 minutes, say, if you solve 100 questions in first 30 minutes, you can leave the exam if you score more than 70%. Second, the basics of security, that is CIA triad, confidentiality, integrity, and availability, which we always strike a balance of whenever choosing the controls and whenever it comes to security. Then we talked about frameworks. Frameworks basically are blueprints of how we are going to implement a control. And there can be multiple views to frameworks, and there are multiple frameworks. Then we come to risk management framework. That is basically a framework which drives the risk management process of an organization or risk management policy of an organization. Then we come to risk assessment and risk analysis. We talked about how risk management is an overarching thing. Then you take one critical activity of the organization, we run risk assessment on it, and then for individual threat actor, we can do a risk analysis. So that is how these three things are related, and we already had discussed about it. Then we come to people, as in when it comes to people are the prime most priority to secure. Then we went to canon of ethics, that is ISS square canon of ethics. There were 4 canon of ethics. There were three cases in which one can raise a complaint against the breach of the canon of ethics. Then there was risk treatment planning. After risk analysis and risk assessment, you come to risk treatment and you put the controls in, and whatever risk that remains in the environment after we have put the controls becomes your residual risk. Then we talked about policies, procedures, baselines, and guidelines. Policies are enforceable, procedures are enforceable, but more granular, step by step on how to do something. That is procedure. Then baseline is point in time configuration that shall be met always and every time in similar systems. And then guidelines are non-mandatory, non-enforceable type of good to have things. Then we went to asset inventory, data classification, categorization, labeling, and marking. Asset inventory is basically pointing out where your particular asset or data is located in your environment. Then classification means how what kind of sensitive data is there in that particular inventory, and so that you can prioritize your time and effort in securing the data. So for example, if you have some secret data stored in some database, you'll put more time and effort in securing that than something which is storing a public data which is already made public. So there's no it doesn't make much sense to prioritize your time and money securing the public information which is already public, than when you have some sensitive data, some top secret data which is still lying unprotected. So that is why we do the classification. Then we come to categorization. In categorization, we figure out the theme around the kind of data that we have. For example, we talked about Aadhaar card and PAN card and whatnot. So these are all fall into PII. So if you're going to if you have figured out all your asset inventory, all your data inventory, then you can categorize it as these are the databases which are spread across multiple applications, are having similar kind of data. Hence, these are PII data, my PII data. Stuff like that. So that is categorization. Categorization is finding a common theme running across the all the data pools that you may be having in the organization, irrespective of the applications in which you are using. For example, your HR may be using that PAN data of a user or Aadhaar data of a user. Similarly, your banking and your finance team may also be using the PAN and for taxing purposes and whatnot. So both are using PAN details, and both may be having different applications. So applications are different, but the nature of data is the same. So hence that is how you categorize the data. You make it PII data or something similar. So there's no hard and fast rule about that. You can have your own categories. You can choose your own categories to club the data pools into. Then labeling and marking basically are instructions on how to handle a media. For example, if you have backup tapes, you can put the environmental conditions that shall be there. You can state the rotation policy. How often do you need to change the backup tapes and stuff like that. Then we come to roles, as in data owner, custodian, steward, and processor. Data owner is the person who decides what kind of classification or what controls do we need to put in. Then custodian comes in. Custodians are responsible for the technical controls when it comes to the, so data owner will define key, okay, I want this kind of an access control, maybe RBAC, role-based access control, or maybe context-based access control on the databases. Then it comes to custodian. Then it becomes custodian's responsibility to ensure the technical tools which are required to enforce that requirement of data that is submitted by the data owner. Data steward is somebody who ensures that the data which is collected from data subjects is something that makes business sense. For example, if I'm running a business and that requires me to collect demographic data, say the age of the people who are my customers, and the height of the people, and their state of residence and whatnot. So steward is somebody, and the processor or whoever is collecting the data from the subject. So subject is always somebody whose data is collected. So when I collect these data items of the subject, steward is somebody who will ensure that this data makes my business sense, because there's a point in not storing more than required data, because then it becomes your liability to secure that data. So that is where stewards comes in. They ensure that whatever data is collected has a business case attached to it, and hence it doesn't become a additional liability on the organization. Then the data processor is somebody who processes the data to transform the data into information for the business to make decision or make informed decision, so stuff like that. So processors are basically processing data to make some meaning and help the business case. Then we come to data lifecycle. That is acquisition of data till defensible destruction of data and whatnot. So there was an entire life cycle where I illustrated that how do PDCA work here. You plan, do, check, improve, and act. So that was there. There was a cyclical approach to it. Then there was protection of data at rest, in use, and motion. So we talked about how, and for data at rest, we can use encryption to do it. But whenever it is in use, that is in memory, it needs to be in the plain text form that is decrypted for the system to operate on it. So that is where it is most vulnerable. When it is in use, when it is in RAM, it is most vulnerable. The data is most vulnerable. And then in motion, you can use tunnels and encryptions and whatnot. So that is what we have already discussed. Now moving on to the remaining questions that we are having from the previous sessions. So from the previous two sessions, again, we are coming back to the questions, and the strategy again is the same. I'll show you maximum 2 questions at the time, and you'll be having 10 seconds to give me the answers in the chat box. You just drop in the letter of option, say A, B, C, D, 4 options are there. You can simply put A, B, or C, or D in the chat box. Okay, proceeding. Here it is, the 5th question. Which of the following is the least effective security control regarding sensitive data stored on mobile devices? So option A is backup all devices to an organizational managed repository. Option B is implement full volume encryption on all mobile devices. Option C is require that all mobile devices be wipeable remotely if stolen or misplaced. Option D is enact a policy prohibiting the access or storage of sensitive corporate data in personal mobile devices. Your time starts now. Okay, so data steward, we can discuss about it at the end of the session. Who was it? Sharma S47, if I'm not wrong. Yeah, we can discuss about data steward by the end of the session. Time starts now. Sorry, I got distracted. And your 10 seconds are up. I can see people are confused about this. So yeah, let's discuss it out. Let's figure out what is happening here. So first keyword is least effective. Okay. So we'll focus on, this is a not type of a situation, which is not the security control regarding sensitive data stored on mobile devices. So backing up data on organizations managed repository is a good idea because it is a managed repository, since hence organization is having all the control over the data. And whenever your mobile device is lost or something, if you need to remotely wipe it, you'll have at least one replica of data available. Then B is implement full volume encryption on mobile devices. Say your device is compromised now, and it is powered off, somebody is trying to steal the data away from it, or is trying to maybe unlock the bootloader or something to compromise the operating system, and then get elevated access to your device and compromise your storage. And so there your full volume encryption comes in. So that is also a required control. Then require all the mobile devices to be wipeable remotely. That is a very important control, because say if you have lost the mobile device, you at no cost are willing to compromise your company data. So what comes here is enact a policy prohibiting the access or storage of sensitive corporate data on personal or mobile devices. So now everybody will shout at me, because during the last 2 sessions I've been telling you that every time you see policy is the most superseding thing that you see, and your option, whatever option carries policy, is always correct. So here is going against my own saying, this option is the correct one. So even if you enact a policy and you're not enforcing the right controls on the endpoints, because here nobody has detailed. So what they are asking here is you enact a policy to prohibit access or storage of sensitive corporate data on personal mobile devices. That is out of context, because then you have to have a policy also stating that you do not. So basically what they are trying to say is you cannot use or you cannot store or use any of the corporate data using your personal mobile devices. And that does not, that is nowhere related to whatever is here. So even if it says policy, it has policy. Yeah, sorry, but policy is high level thing. Then how come it is least? Yeah, that is what I'm coming to. So this question talks about. So that is why I was able to sense this kind of a civil war going on after I put this question out, that the one we can see in the chat right now, and hence I was well prepared for it. So what they are stating here is regarding sensitive data stored on mobile devices. Okay. Now they are not saying whether it is a personal device or corporate managed device. And here what they are saying is sensitive data on personal mobile devices. So say I have enacted a policy which prohibits accessing or storing sensitive corporate data on my personal mobile devices. What guarantee is there that I do not have a device which is issued by company, which is managed by company, and that is the kind of mobile device that we are talking here. So D is the right option here. Yeah, you got it right, Sharma S47. That is the point. So they are basically trying to lure you guys by stating policy here, so that, yes, I'm sorry. So they are trying to lure you to the policy word, but you'll have to pay attention to this part, that they are saying mobile devices, and here they are saying personal mobile devices. So whenever this policy comes into picture, it will focus on just personal mobile devices and not all mobile devices. Shan, that is not the primary reason why, but yeah, the coverage of this policy will be on personal mobile devices. And here the question asks mobile devices in general. So it can be personal, not personal, corporate managed, and whatnot. So it is broader in that sense. Option A can be relevant to security controls. Okay, security controls. Security controls we have talked about now. There can be preventive security controls, deterrent security controls. Then there is one called recovery security controls. So this is for recovery. Okay. If you're done, we will proceed to then the question number 6. In modern era, are paper records still a significant concern in the protection of enterprise data assets? If so, why? If not, why not? So here is your options. Yes, because the most sensitive data is usually stored in the printed form. Option B is yes, because printed copies are still commonly produced, are more difficult to track, and are commonly not disposed of properly. And C is no, because the amount of sensitive data that is ever printed out is exceptionally small by comparison. And the option D is no, because sensitive data that is printed out is the easiest to properly destroy. Now your time starts now. You have 10 seconds. You leave your options in the chat box. Your time's up, guys. And as I can see, all of you have gotten it right. It is option B. Tell me in the chat if anybody needs an explanation for this, or else we'll move on. Okay, moving on. Question 7 is, a business impact analysis is considered a functional analysis. Which of the following is not carried out during a business impact analysis? Your options are A, a parallel or full interruption test. B, the application of a classification scheme based on criticality levels. C, the gathering of information via interviews. D, documentation of business functions. Your time starts now. Okay, your time's up. So what they're asking here is, okay, everybody have received your answers. And since there is a clear divide in the options, so we'll discuss this question. So which of the following is not, okay, not carried out during a business impact analysis? What is not carried out? You documentation of business functions, you'll do it because when you start a BIA, what you first of all do is you set the context of organization. And when you're setting context of organization, you identify the key activities that an organization performs. So you definitely are going to document the business functions. B, then we come to this gathering of information via interviews. So yeah, you'll interview individual application owners in order to identify what threats do they think are to be rated. So we have learned about this 3x3 qualitative matrix. So we'll interview the business application owners, and then we'll in this qualitative map, we'll map out the threat severity. And then the application of a classification scheme based on criticality level. So I'll have to identify the criticality level of a business function or the key activities in order to A, prioritize my efforts in securing that asset, and similarly, yeah, prioritizing my finances and efforts. So it is a parallel or full interruption test that you won't perform because it is an activity of a DR drill. Okay. In a parallel or full interruption test, what we do is you have you have application 1, and application 1 is you have application one and you have two locations. One is your data center primary and second is your disaster recovery site. Application one, the entire infrastructure is here as well as another replica over here. And there is log shipping and whatnot in between. So this remains in sync. What you do in full interruption test is you cut it here and then your application one, what you do in here is, so yeah, this is your application one, and there are two environments set, one in DC, one in DR. What in full interruption, what you do is you cut it here, you power it off this instance, or you basically isolate it on network, and then application is diverted to the secondary instance. Exactly. And in parallel, what you do is you keep it on and you simply divert the traffic over here. So that is a simulated DR run of some sorts. Though, so the option A is nowhere related to what is asked in the question. Hence, it is not. So option A is correct. Going to question 8, we have which of the following steps comes first in a business impact analysis? Okay. There you have options: calculate the risk of each different business functions, identify critical business functions, C, create data gathering techniques, and D, identify vulnerabilities and threats to business functions. Okay, guys. Yeah. Done? Okay. So there again is a small divide in the chats, as I can see. People are divided between B and C. Let's figure out this question. What is going on here is, just a second, give me a second. Yeah, what is going on here is calculate the risk of each different business functions. Yeah, we are going to do that, but not each different business functions. We'll identify the key activities first before that. Then identify vulnerabilities and threats to business functions. That is part of your analysis and assessment. So that is not there. Then you create data gathering techniques and critical business functions. So the only dispute that one may have is between these two options. And we'll go with this one because whenever you go to perform any activities in an organization, you start with context of organization. When setting context, you chalk out policy first of all. So this is kind of that. We figure out the data gathering technique that we are going to use. Say I'm going to interview everybody, or I'm going to use Delphi model, or whatever technique that I'm going to use. However, I'm going to collect the data required for. Although my answer B, but only but when exactly. So critical business functions are the first one which comes. So you have to, in case of a BIA, whenever you start anything procedurally, you set the context first. But in case of BIA specifically, you identify the key activities. But since they have talked about data gathering also, create data gathering technique, that comes in setting context itself. So when you're setting context, you figure out, you try to standardize the data points that you're going to use in the entire process. So that is why data gathering techniques takes precedence here over critical business functions. If only it was not there and something else was here, critical business functions would have been the right answer. But since data gathering technique is there, that comes to context. So that is why option C is correct here. Okay. So in case of BIA, identifying critical business function is the first step towards that. But whenever we start anything procedurally, this BIA is not running alone. It must be there in your RMF. So you must be having a risk management policy or risk management framework in force, within which you are conducting BIA. BIA is not a activity which you do, which lives in isolation. So even if you do a business impact analysis, what are you going to do? You'll have to do RA, then you have to do RTP of that, and then you arrive at the new residual risk that is there. Okay. So that is why you do a BIA. You do not do BIA to just do BIA for the sake of doing it. It does not live in isolation. So since it is a part of a greater RMF, and then when you go to RMF, you will be setting the context of organization first. When you're setting the context of organization first, your first thing that you do is you identify the kind of data point that you wish. Therefore, BIA should come within the, yeah, it is within the RMF itself. So within the BCP context, yeah, it is all. So these are all related. These does not live in isolation. You perform a BIA just to understand how and what kind of things can impact your key business activities, which hinder your business operations, and to what extent. So that is why it is not living in silo. It is living with different things altogether. And when it is living with different things, data gathering techniques takes precedence. Although if it was just a question of BIA and there was no data gathering technique here, I could have easily gone to identify a critical business function. I hope everybody agrees now. And cool. If you have any doubts related to this, we can at the end of the slides, we can discuss about it. Okay. So question 9, Megan wants to prepare media to allow for its reuse in an environment operating at the same sensitivity level. Which of the following is the best option to meet her needs? Clearing, erasing, purging, sanitization. We have had a similar question last time around. Your time is running, and okay, there's a divide. I don't know why. Okay, cool. 10 seconds are up. And there is a divide again. Wow, cool. This is interesting. So yeah, shall we discuss it? Because there is a divide in the people. Yeah, media reuse. Reuse is the keyword. Reuse is fine. Reuse is all right. Reuse is one keyword. Another keyword is operating at the same sensitivity level. That is what we had discussed last time around. So that is why, yeah, A is the correct option. Erasing and purging can be eliminated. Sanitization again can be eliminated, because sanitization makes the primary objective of sanitization is making data irrecoverable. But if I'm going to use it in the same context, same security context, then I can simply format it and bring it back. So clearing is basically deleting everything. Erasing is a bit harsher than clearing. So you overwrite everything with zeros and whatnot, while erasing it. And then purging is physically destructing the media or making the data, again, purging is again related to making the data irrecoverable. So sanitization and purging basically deal with making the data irrecoverable. So that is their primary objective. Although they'll give you a clean disk that you can reuse, but since you're going to use it in the same security context, you can simply delete the contents and continue. So clearing is the least effort thing here. Now, moving on to the 10th question. Jacobs organization uses the US government's data classification system, which includes top secret, secret, confidential, and unclassified rating. The most sensitive to least. So top secret is the most sensitive and unclassified is the least sensitive. Jacob encounters a system that contains secret, confidential, and top secret data. How should it be classified? You have four options. You have 10 seconds. Your time starts now. And your time is up. Wow. Most of you have gotten it right. Yeah, most of you have gotten it right, and one of you has explained it also. So yeah, It is a very easy question. It is a simple concept question. So whenever you have a mix of data in whatever asset you are classifying, you choose the highest classification. For example, even if I have a single bit of data which belongs to top secret, no matter how many pieces of information are in confidential or unclassified, it will still be top secret because it contains at least one bit of top secret. And to ensure the right kind of confidentiality enforced on the media, I'll have to ensure the uh, confidentiality measures which align with the highest rating that is there. 11th is Chandra wants to secure an encryption key. Which location would be the most difficult to protect if the key was kept and used in that location? A is on local network, B is on disk, C is on in memory, D is on a public network. Your time starts now. It's an easy one. You guys can simply just nail it. Okay, your time is up. The problem is there's again a divide. So yeah, I've seen the options and there seems a divide. There's no consensus. So whenever there is a consensus around you guys, I do not discuss the questions because I know that you guys know the concept and we can skip that. But in this case, there's a divide, so we'll discuss it. So what they are saying is, first of all, what you're protecting is a secure encryption key. So if you compromise the key, then encryption is of no use. It is as simple as plain text then. Okay. Yeah, it is public key is shared. All right. No, already right. No. It is not about asymmetric encryption where you can use public and private keys. There are two sets of keys and public remain public always. So it is not that. They're talking about what they're trying to infer here is it is an encryption key that is symmetric encryption algorithm is used, and hence if you compromise the key, your cipher text will be as good as plain text. So the encryption will be of no use. So which is the most difficult? Difficult is the keyword here. And what is the most difficult here is on local network, it is sitting on hard disk itself on some server. So you can use full disk encryption. On disk, it is again local only. On public network, it is again data at rest. So all these three cases, what is common here is data is at rest. And when data is at rest, you can protect it very well. But where it is most difficult to protect the data is when it is in motion, when it is in use. So this memory thing, data is in use here. So that is why it will be a bit more difficult to protect it when it is in memory because of it is in use. When it is in use, it must be in plain text format for the system to process it. And that is why it becomes difficult. So they asked difficult, and there was so whenever you have a doubt in as to what option is right, try to eliminate the options, try to find a common theme around it, just the way I did it here. Yeah, on this makes sense, but we have other options as well, which so the context here is not where to keep that key. The context here is wherever I keep the key, which one will pose the most difficulty in securing the key there. And there's a common theme here, no? On local network, data is at rest. On disk, data is at rest. Public network, data is again at rest because it is some way or the other sitting on a hard disk. Data in motion. Okay, data in motion, I'm sending it on as an email attachment to somebody else. That is data in motion. If I'm sending this key as an email attachment, that is where it will become data in motion. Or say I've established a VPN tunnel between my corporate network. No, in this question I'm asking. No, there's no case of data in motion here. It is in memory, so data in use. Local network, it is already sitting. Public network, it is already sitting. On disk, it is already sitting. Data in motion can be motion is when it is on line, on wire. So whenever data is on wire, it is moving from one place to another, then data is in motion. And when it is being actively processed, then it is in use. So whenever non-volatile memory comes into picture, generally, as a thumb rule, you can say that whenever non-volatile memory comes into picture, so say NV memory, it is in use. Sorry, NV memory, it is in rest. It is at rest. Volatile memory, it is in use. And network, it is in motion. That is how you can try to understand it. That is how. So in summarily, you can use this legend over here to understand. So whenever there is a non-volatile memory, as in any of your secondary storages, it will be data at rest. And volatile memory, it will be in use, and in network, it will be in motion. Okay. Coming to the 12th question. Mike wants to track hardware assets as devices and equipments are moved throughout his organization. What type of a system can help do this without requiring staff to individually check barcodes or serial numbers? A is visual inventory, Wi-Fi MAC address tracking, RFID tagging, steganography. Time starts now. Oh, it's an easy one, huh? Half time. And your time is up. So since I see that there is no divide and everybody is agreeing to RFID tag, we'll move on. Okay. And by the way, if anybody can tell me steganography, they can hold the thought and we'll discuss it out by the end of it. Okay. Thank you. Yeah, there'll be the domain 3 today, but some people have asked me to include up to 20 questions in the slides. So that is why I'm including around 20 questions this time around. So here's the 13th question. John's network begins to experience symptoms of slowness upon his investigation. He realizes that the network is being bombarded with TCP SYN packets and believes that his organization is a victim of DOS attack. What principle of information security is being violated? So anybody who can tell me about how a TCP handshake also happens by the end of the session, it will be also good. So 2 things that you guys are going to tell me by the end of the session. Your time starts now. Yeah, you guys are smart. So yeah, there's no need to give you additional time. Everyone is right. Yeah, you are smart. Synac. Yeah, cool. Yeah, when we discuss it now, we'll break it down. So then we'll understand who is so smart, who is smart, who is smart. So pin it. We'll discuss about TCP handshake, and we'll also discuss about this steganography. Okay. If anybody can remember this for me, please do that. Now, 14th question is, Alan works for an e-commerce company that recently had some content stolen by another website and republished without permission. What type of intellectual property protection would be best to preserve Alan's company's data or company's rights? Yeah, again, you guys are super smart. It was a theoretical question, and yeah, you guys are right. Copyright it is. So whenever you copy some material without permission, it generally is a copyright infringement. So now we'll proceed to the domain 3 of CISSP. Thank you for being here so far. Materials copyright. Yeah, materials is copyright. If you're talking about CISSP study material, yeah, it is. So yeah, thanks for all the 83 people who are still here. I request you guys to please fill in the feedback form whenever you get time to, but preferably by the end of the session. Expression of idea copyright, expression of ideas. If you have already documented it somewhere, yeah, it is. Okay, yeah. Domain 3 is security architecture and engineering. And then here we'll talk about, here we'll primarily talk about the system architectures, encryption, your security models, and stuff like that. So yeah, it will be an interesting one, I guess. So first of all, let's understand what system architectures is. And before that, let's break down the system for you. System, what is a system? System is anything which is, system is basically a component of a system. We can define system as something which is, which gives you on an input, a predictable output. That can be your system. So any system, whenever we talk about system will be something that when given input, a certain input gives you a predictable output. So that is a system. System architectures. System architectures deals with a multitude of multiple systems interacting with each other to drive the business objectives. So what do that mean? That was very cryptic, I guess. So what does that mean? Say you have so in your organization, say you have a application, a website on which there's n items listed. So on the back end, whoever is a system admin will be able to tell me that there's a web server, there's an app server, and there's a DB server where everything. And finally, the user request lands here, and that is how user sees this website. So behind a website, at least 3 servers and a network and host of other devices, say firewall, is working in tandem. So each and every of these is a system, and this is a system architecture. So when 2 or more systems interact with each other to drive a business objective is my website, and 2 or more systems are my web server, app server, DB server, firewall, my network routers which are sitting here, my switches which are connected here somewhere. So all these individually are systems because they are performing one single function, and all these are working together to perform this business function, that is my website. So this is a system architecture which defines how these will talk to each other, and individually these components will be systems. I hope that makes sense. If it doesn't, we can discuss further by the end of the session. System, anything which stores, processes, transact data. Yeah, you can do that. So there are no hard and fast definitions. Maybe if you wish to refer a book, you can get a hard and fast definition, but every book then again will give you a new definition of a system. Okay, now moving on. Then there can be client-based systems, meaning one agent is sitting on your computer and doing whatever is required. Say the good old days when you didn't need internet to have something. For example, you can say what application in your phone, if you look up any application which doesn't require something delivered. So if you remember back in good old days, we used to download MP3 files on our phones, and or maybe the media players, and that music player application which was sitting there, it didn't require to reach out to any server. It was fetching the data from the storage from the storage which is on board on the machine itself. So any system which does not require to talk to a server to perform its intended function is a client-based system only. So that MP3 player is a type of client-based system which does not require a server to function fully. Now, what is a client-server function? Client-server system. Client-server system is basically, say, any of the modern-day applications or games. Say your Facebook application. If one day Facebook server on the backend is down, then you won't be able to. Your feed won't refresh. Or say Instagram. Again, it's a website covered in basically a web page of which wrapper is their application. Application is wrapping that web service and maybe running a few API servers on the backend. A server is having multiple APIs which are feeding the data to this application. So in order to these kind of systems do require a server to feed them with data, and then the parsing of data happens on the end user machine. That is a client in this case. So that is a client server approach in which server takes care of some part of the responsibility and the client takes care of another part of responsibility, and that is how you form a client server architecture. You form a client server system. They can have entire architecture system. So like in the beginning, I've told you that there's a web server, there's an app server, and then there's a DB server. Then there is a DB server. Your web, your app, your DB. So this is here I have 3 tiers. I have 3 systems which are serving their own unique purposes, and that is how we design a n-tiered architecture. It is a 3-tiered architecture. I can have more than this tiers if I want to. Maybe I put a load balancer which lands requests to multiple web servers. Then with each web server lands to another load balancer. Then there are multiple app servers behind it. Similarly, I have maybe after this app, again, there is a load balancer. Then there is a read replica of this DB, and there is one master replica which everything writes, but when there is a read operation, it goes from read replica itself, and it is running OLTP maybe, or in-memory database or something. So architectures can get complicated very fast, and this was a typical n-tier architecture. I've minimized the chat, so I won't be able to look at the chat. So if you guys are typing something, I'm not seeing it, just know that. So now database management system are simple databases. And yeah, do I need to explain database management system? Database management system basically are pool of data. They can be of two types primarily. One is relational, which runs on SQL. Then you have NoSQL, which is not only SQL. So you have in not only SQL, you have key value pairs. You have so what relational data is, relational databases. You have a primary key. You have tables. You have multiple tables, and you have keys in every table. You have rows and tuples. So these are rows, these are tuples, and any value which is stored here is a key. And now you can map out keys across tables. So say I have a table which has stored my PF number along with my name, along with my address. Then there is another table which has stored my PF number, my gross salary, my tax liability, and I want to represent, and I want to fetch data pertaining to my which contains my PF number, my name, my tax liability, and my gross salary. Then I'll have to fetch data from these two different tables. Okay, then that is where I run a SQL query, and this is kind of how how relational databases operate. So they have whatever value, whatever key which is there common in the both tables is called a primary key, and primary key is used to link two or more tables. So when I run a SQL query on a relational database like that, I'll be able to query multiple tables based on the primary key that I'm using to fetch data from more than one table. And in case of NoSQL, you have multiple options to, again, similar to that, you have JSON to interact with the data which is stored on NoSQL databases. And then again, NoSQL databases can be of many types. One which is very popular is key value pairs. You can read about it. You can read about it separately, or if you want, we can discuss it later on by the end of the session. So this, every database has something called ACID property. ACID property basically is atomicity, consistency, isolation, and durability, which deals with basically transactions. So whenever you're, so in databases, the important part is if I'm writing something, it should be written completely or not written at all. Okay, so that I do not have any confusion. Whatever data I've put here, basically it deals with integrity. So if I'm writing something, it should be written completely and or should not be written at all. That is what we call a transactions. Transactions is reading or writing to database, to or from database. And all transactions have ACID properties, that is atomicity, consistency, isolation, and durability. Durability is when I've written something, it shall remain there and it shall not move. Isolation is the same thing that I've told you, that if I'm writing something, it shall be written to and shall not be changed. Till what time? Yeah, I think I'm taking just too much time, so I'll run through it. Cool. And then we have for NoSQL, we have basically CAP theorem. CAP theorem basically deals with this partition tolerance and availability, and all three cannot be delivered by one system at the same time. So we have to prioritize either CA or AP or PC. So CAP theorem is that, you can read about that. Then we have industrial control systems. We have programmable logic controls. We have RTUs, that is remote terminal unit. We have distributed control system, and we have SCADA. So what the difference between DCS and SCADA is, in case of SCADA, these RTUs. So what is an RTU? RTU is, what is a PLC? Programmable logic control. Basically, in industries, you have nozzles and whatnot. You have to deal with physical devices, and the way you interact with physical devices is with programmable logical controls. And these sort of function like actuators. So say you have a tap which fills in a tub, which fills in a boiler eventually, or maybe you have a tap which fills in a boiler. So on tap, you'll put a PLC, and an RTU, remote terminal unit, will take data and instruction to this tap, this PLC, and PLC will in turn turn on or off based on the RTU's instruction. So that is a local industrial control system. When you network these systems, these land on a DCS, which is a distributed control system. So a DCS will be connected to multiple RTUs, and each and every RTU will be connected to some PLCs. When you bring it to a bigger network, then you come to SCADA. SCADA is basically your supervisor control and data acquisition. So basically, it is a big brother of DCS. So DCS was small. DCS was generally for local network context. SCADA is for bigger networks, industry control systems. Then you have virtual systems, so basic virtualization like Hyper-V or something, which is already there in your Windows machines or whatnot. You can use VMware Workstation Player for to get a taste of virtualization system. Basically, you have a hardware on top of which you can make multiple virtual machines to maybe for purpose specific. Say you want to imitate a network, you want router, switches, and whatnot. So you can emulate that kind of things with a virtualization layer. Then you have cloud. Cloud can have multiple types of implementations. One can be public, private, or hybrid. Public is basically AWS, or you must have heard of Azure, which is run by Microsoft. So these are public cloud options. In case of private cloud, your organization itself set up all the hardware, everything, network, etc., and runs basically a virtualization layer on this entire hardware to sort of mimic a cloud. And in case of hybrid, your some of the workload sits on your cloud, public cloud, and some of the workload sits on on-prem. On-prem is your on-premises hardware. Okay, and then there'll be a link channel in between, and that is where the question of identity comes in, because in cloud you don't have, in public cloud you don't have much control on how your information asset is dealt with. So the only and the most important control becomes how well you are able to identify who is accessing this. So that is where your CISSP comes in, Cloud Access Security Broker. It works as a proxy or a PAM, privilege access management. Sorry, privilege access management. So what it does is you land on this gateway, which is sitting on this cloud service provider cloud front, and once you prove your identity here, then only based on your whatever rules the organization has set for your particular user ID, you get the access to those resources in cloud. So that is how CISSP functions. Then cloud can be IaaS, PaaS, SaaS. So I stands for infrastructure, P stands for platform, so S stands for software, and AaaS is for as a service. So infrastructure as a service, platform as a service, and software as a service. What is the distinction is how you're segregating the responsibilities between the cloud service provider and your organization. So in case of IaaS, this is your cloud service provider, this is your cloud service provider, and this is your organization. So organization takes care, cloud service provider just gives you the hardware, say 2 CPU cores, 64 GB RAM, some 1 terabyte storage. That is what they'll provide, and they'll take care of firmware, etc. Behind the scenes, and they'll take care of the hardware and redundancy and whatnot based on your SLA, service level agreement. And your organization's responsibility will be to either install a virtualization layer on it, or maybe install a host operating system on it, guest operating system, applications, application patching, OS patching, putting baselining the OS, baselining the application. Everything comes on your organization's responsibility. In case of a PaaS, what you get is you get operating system. Your cloud service provider will give you operating system. So they'll take care of the OS patching, they'll take care of OS baselining and whatnot, and you'll take care of application which is installed on top of that OS. Okay. And then it comes to SaaS. What SaaS is? SaaS is basically software as a service. You get entire application which you are going to deploy on top of this infrastructure on this OS. That application will be delivered to you as a service. So maybe if you have HRMS system, or maybe take example of Facebook. Facebook is a website which is delivered to you as a service itself. You do not see what is behind the scene, what operating system is it running on, what kind of applications it is hosted on. So that is the kind of environment that you get in SaaS. Sorry, I'm rushing it because we have already reached 7 o'clock and we have not even scratched the surface. And I really want to finish the cryptography part. So now we have IoTs and embedded systems. So embedded systems are basically purpose-specific systems. Say you have your FPGAs or maybe ASICs. So these are the embedded systems. Your IoTs are basically network connected brainless devices, not so smart devices, which are network connected. For example, your connected air conditioner, which you can turn on or off, or you can tweak temperature off using internet. So these are basically network connected devices, which are not so smart. And hence they pose a challenge when put in too many numbers in the organization, because tracking and securing these becomes difficult. And since there's a resource crunch, non-standard hardware is used there, it becomes a challenge to patch or secure the things accordingly. Because if you're using heterogeneous environment, if your hardware and software is restricted in nature, it will be very difficult for you to then not standardize any policy. For example, then you'll have to look for the solutions which work on all the diverse type of solutions, hardware, software that you're using in the environment. So it becomes difficult. That kind of a challenge is there in case of unrestricted, unconstrained use of IoT and embedded system. Then we come to distributed systems. Distributed systems can be of two types: edge and fog. So edge, the simplest example of edge is if you've heard of CDN, that is content delivery network, which is say you're sitting in India. This is India and this is North America, and there is a website which is hosted, which is having their servers here only. So just to get a ping response from here till here, there'll be some latency. So this round trip latency will be there. CDN, not YouTube. Yeah, we'll discuss about it. Try not to distract me. I want to just finish it because there are a few good things which are there in the next few slides, and then there is some content left. So yeah, please do not distract me with chats. Okay, so edge devices, the best example of edge device is CDN. CDN, how it operates is, say you have some server sitting in North America and your customer is sitting in India. Now, because it is the internet which you're accessing, this customer must be having an ISP, internet service provider, which has given an optical cable here. Then ISP may be having some switching network in there, and then they'll have undersea cables going there. Then they'll have another ISP which has given an uplink to your service provider. So there are too many things in play, and all have got some latency, some processing time in it. So it introduces some delay, and there can be some time sensitive applications which the customer is accessing. For example, say tomorrow WhatsApp sets up all their servers in America itself, and there is no servers in India, or there is no CDN, or there is no edge devices. Then whenever you place a WhatsApp call or WhatsApp video call, it will go to that server in US, then come back to India and to whatever person you have called. So it will relay like this, and it will introduce a latency in the environment. So why we use edge devices is we create a cache of that particular application which is located in North America in the nearby location. Within India, we'll put it in maybe Bangalore, then again somewhere in Mumbai, then again somewhere in UP. So we try to put a cached replica, cached content of this actual application in a closer location to the a location which is closer to the user. So that is where your edge computing comes. Then your fog computing basically is your sensors. So say your sim loggers or connectors are sensors which take syslogs from servers and deliver it in a syslog server. Or maybe your just like PLC is a fog computing device, basically because it is a sensor, it senses and then acts accordingly. So fog computing devices you can understand as sensors. Then what are the typical vulnerabilities which are found in systems? That is single point of failure. Say you have a router and you have an application hosted behind it. So you have a server running here. And then here is my innocent user who wants to use this particular application, but your router somehow goes faulty, or somebody launches a DOS attack on you, DDoS attack on you. Then your router gets overwhelmed, and hence the user won't get it. Even if you have multiple servers located here to serve the same application, user won't be able to access it because the one node preceding it is a router, and there was a single router which was overwhelmed, and hence there was a single point of failure. So that is why we put redundant systems. So how do we do redundant systems? We'll put one router, we'll put another router, and there'll be a virtual IP address somewhere here. User will connect to this virtual IP address, and then the load will be either distributed, either I can put it in active mode. So in active, the load can be distributed across the two. Say one request comes, it will land here. Then the second user comes in, the second request comes, it will land here, and then it will go here in the application servers. Okay, so that is how we put redundant servers. Either we can do active or we can do active passive. So one router remains active all the time, and once this router goes down, this will take the full load. So this is how we can do redundant systems. We can do active or active passive, and redundancy is there because just in case if your system fails. Bypass controls. Say you have a server which is having integrated light out. Okay, so ILO or ID rack you must be familiar with. So ID rack is, these are basically lights out management system. Basically, if you have a computer, if you own a computer, once you boot it, there is a BIOS splash. So there's a post message which says that press F2 delete or F8, F10, F12 to go to your BIOS or UEFI environment. So in order to access that kind of a low-level configuration page on a server over network, you can use lights out management system, which is an ID rack and ILO, which is what an ID rack or ILO is. Okay. So now if you have a low-level access with ILO and you have also put a PIM here. Okay. So you have enforced RBAC here in the PIM. So you have enforced rollback access control, and whenever a user comes in, they'll have to show their identity. You'll have to show your MFA, your credentials, etc. And then only you'll be allowed to enter with restricted privileges, like you cannot read or write between to or from server. But at the same time, you have also allowed ILO access also on the network. Say this user gets access to this ILO server. He won't need to come to your PIM. He won't need to use MFA. He won't even need to give you their credentials. They can simply use their ILO credentials and land into the server. So this is what bypass control looks like. This is one such example. Bypassing control is whatever control you have put, somebody can bypass it and to land in the same, get into the same resource with the required access and privileges without going through your regular control measures that you've put. Now TalkTow is time of check, time of use. So say you have a website that you visited, which after authentication gives you a small cookie in your system. Cookie is basically a text file which stores some parameter, say your website preferences or your authentication details. Okay, so what TalkTow means is then the web server will constantly keep on checking whether your session is active or not, and say there's a duration of 30 minutes, that this is how often the website checks whether you're authenticated or not. And between these 30 seconds, between these 30 minutes, if say cross-site with cross-site request forgery or cross-site request forgery, somebody gains access to your credentials. If you have shared the credentials across multiple sites with the same credentials, with the same cookie on a different site, then it is a talked out, because your server is checking it in every 30 minutes. And within that, cross-site scripting is not that, it is a request forgery basically. Scripting, we'll talk about it. Okay, since you have brought it up, we'll talk about it. Cross-site scripting, actually I was interested in this, explaining that. That is why I've mentioned it over there. Now coming to emanations. What is emanations? Emanations is basically radiation. So whenever you're running operations in data center, you know that there'll be heat loss in the environment, and based on that, or maybe your cell tower is radiating at certain frequency, which is unprotected or unencrypted. So somebody can tap in. Tempest controls is what we use to counter emanation. Then you can have covert channels, just like your bypass controls. You can have covert channels. For example, covert channel bhi bata do yaar. So your covert channels are basically which are not known to everybody, which are not well documented. But anyways, you can tap into your system. For example, one covert channel can be the processing time required by a server to encrypt or decrypt requests. By that, you can understand what kind of algorithm, what kind of key length is being used and all. Then you have mobile device vulnerabilities, which is very well captured in OWASP's top 10. So I wanted you guys to, we'll discuss about everything at the end of the session. So yeah, so then vulnerable, your mobile devices can be vulnerable. And there is a very good, okay, OWASP top 10 is a very good repository of mobile vulnerabilities related to mobile devices. You can go on their website and look out. So that is what I wanted for you to be as a homework. So if you guys want to further read, go to OWASP's website and check out top 10 mobile device vulnerabilities. And maybe go to NIST also. NIST also has free materials, unlike ISO. ISO is paid, but NIST is free. So you can go and check out some standards also on NIST. Then cross-site scripting. What cross-site scripting is, it basically is your web browser is designed to process whatever information is received by it. It doesn't do much input validation, or it doesn't use its own brain. Okay. So how cross-site scripting works is, and it can be of two types. One is stored and other is reflected. Stored is, say you have a website which doesn't do input validation, and somebody in a in one of the posts, or maybe in one of the text field, has put a JavaScript or something, a malicious script. So every time you land on that page, and whenever that content is sent to the browser, the browser, without thinking twice, will execute that malicious script. So that is stored. What is reflected? Say somebody has sent you an email with a malicious JavaScript attached to this URL itself. Okay. Now you have clicked on the URL, the request went to the server, and the server sent you a response, and you have gotten the malicious script running on your browser because nobody has done an input validation, or nobody has filtered the request. So that is how cross-site and reflected cross-site scripting, stored and reflected, are. Now coming to security models. Sorry guys, I'm little bit in a rush. I'm rushing it because we are already at 7:30, and this session should have been concluded by 7:30. So tell me if I can skip this altogether, because the next slide contains cryptology, and I think that is more important from exams perspective. I can tell you that you should read about TOGAF a bit. You should read about Bell LaPadula and Biba also. So I'll tell you about this. I'll tell you about security models. What security models are basically is, models give you it's just like procedures. So here we talked about architectures. Architectures are like policies of implementation, and models are like procedures of implementations. Okay. So models give you a reference to design your own solution on top of that. So what is a lattice-based model? We have talked about categorization. We have talked about top secret, public, and then there'll be multiple categorization, multiple layers of categorization. So just imagine this as multiple layers, lattice. Lattice is layers, okay? Now what Bill Lapidula says is, what Bill Lapidula deals with is confidentiality controls, okay? So whenever I'll talk about Bell LaPadula, I'll be talking about controls, designing controls which deal with confidentiality of data. So what it says is, it simply has three rules. One is your simple security rule, other is star property rule, and third is strong star property rule. So what simple security rules says is no read up, because confidentiality shall be maintained. So the one who is sitting on top, or the document which is rated higher in sensitivity, must be containing something which shall not be known to the people below. Okay, so if somebody is able to read something from more sensitive environment, the confidentiality of this data is breached. Okay, so the simple security rule says that read up must not be required, must not be allowed. Similarly, the star property rule says that no write down. So this is read up, this is write down. Okay, so anybody who is having the sensitive information with them must not be able to write that sensitive information in a less sensitive information, hence again breaching the confidentiality of the information. Okay, and then comes the strong star property rule, which says that read and write, if you have both privileges, then that shall be performed on the same security context. That is, if you have top secret privilege and you have read write both, then you must be allowed to do it in the top secret environment only, top secret with the top secret labeled assets only. Then we come to BIBA. BIBA deals with integrity. Okay, so BIBA ka I is for integrity. That is how you can remember it. And the other one is Bell LaPadula, that deals with confidentiality. So it deals with integrity controls. So, and it is also again a little bit linked with, just for understanding, you can say that it is reverse of Bell LaPadula. So this talks about integrity axioms. So star integrity axiom says that there shall be no write up. So if I do not have the right data, and here is the top secret data, and I write my incorrect data on the top secret data, then the integrity of this data is violated. Okay, so that is what no write up means. And then no read down. So say I have top secret confidentiality data, and there is some misleading information which is not reliable here, but I still read it, and hence now I know something, some other facts which are not real, which are not true itself. So again, the integrity is compromised. So that is what BIMA model says. And then there is another there's another property which is called invocation property, which is a subject cannot request services of higher integrity. So one which is sitting below cannot invoke requests of the one sitting on top. So what you need to remember here is Bell LaPadula deals with confidentiality controls, BIBA deals with integrity controls, and Bell LaPadula basically says that there shall be no read up and write down. That is your Bell LaPadula confidentiality. And this says that there must be no write up and read down. Okay, that is the simple gist of this whole thing. Then one rule-based model that you need to remember, which is very crucial for the exam, is Clark-Wilson model. What Clark-Wilson model says that is you can categorize your data into two, and then there will be a process. So what is this? This is a constrained data item, CDI, and this is unconstrained data item. Whenever a user wishes to, this is my innocent user which doesn't know anything. Whenever my user wishes to interact with unconstrained data, he can directly go to this. Whenever a user wishes to interact with constrained data, it can only be allowed to access it from here. And what is this? This is your transformation process. So this transformation process, what it means is, based on a certain input, it will automatically define what kind of a function shall be allowed or performed on the CDI, and hence controlling or refraining the user to have free access to the constrained data environment, constrained data items. Okay, and then there will be a oversight mechanism which is sitting on top of it, which is called IVP, which is your integrity verification procedure. So it ensures that this is strongly followed. Okay. If you have any doubts, you pin it. We'll discuss after the end of this session. Okay. Cool. Now we come to evaluation criteria. You shall definitely remember this common criteria. Go to any book which talks about common criteria. Remember common criteria. It is very important for the exam, and you know that it is. You know about EL rating and whatnot. So I'll explain the common criteria to you just in a bit. Certification. What is a certification? What is accreditation? So certification, basically, say you are going to implement ISO 27001 controls in your environment. And somebody will certify that. Yeah, okay, these are the controls, 114 controls enlisted in the standard. And out of that, 90 were in your scope, and all 90 are now implemented in your environment. So that is certification. What is accreditation? Accreditation is when a management approves that certification. So on top of that certification, somebody will approve that, okay, yeah, this certification holds true, then that is accreditation. Okay. Now we come to common criteria. Common criteria of certification basically deals with, there are a few keywords that you need to understand here is, first of all, there will be a protection profile. So protection profile basically tells you the type of device that you're going to. So yeah, why do we need common criteria? We need common criteria in order. So if I go to a vendor and ask which is the best firewall that you may be having, or which is the best firewall that I shall implement in my environment, how do I figure out that the vendor is not lying? So that is where common criteria comes into picture to help me better decide as to what controls shall I put in, what kind of tools shall I put in my environment. So yeah, so that is how common criteria is. It is an evaluation mechanism, and just to ensure that you make the right decision, it is there. In common criteria, you have certain keywords, which is first your protection profile. Protection profile basically deals with the type of device that we are dealing with, say a router or a firewall. Okay, that is your protection profile. Then comes your target of evaluation. So TOE, target of evaluation, is the specific model of that router or specific model. Okay, specific model of that router or firewall is what your target of evaluation is, because that is what you're going to buy, and hence you wish to get it evaluated. Okay, now comes your security targets. So now security targets, you must be wanting it to have next generation NGTP features. Therein you get IPS, you get spoofing protection, maybe whatnot, antivirus, anti-malware, anti-bot, whatever, n number of blades are there, n number of features are there. So that is what the vendor has claimed. So that becomes your security target. So security target will become, this firewall shall be a basic firewall feature shall be there, then IPS must be there, then there must be anti-malware, there must be anti-bot and stuff like that. So that will become your security target. As to these are the features that the vendor is claiming, and on this box they are claiming this, and this is the kind of tool, this is the kind of technology that I want to put in my environment. So this is what common criteria looks like, and against that an EAL rating is awarded. So please read about it. It is very important. Now coming to trusted computing base, I think we can skip this because we have already. No, there's no mnemonics for EL 127. You won't need to remember EL 127 all. You just need to know that there are some levels. Okay. You don't need to remember it word by word. Then we come to TCB. TCB is like I've told you about context in the beginning, like people, process, technology, and then controls are also there, like administrative, physical, and technical. So that is basically in what context security generally operates, and what a trusted computing base is. Trusted computing base is basically a reference model of an environment which contains all this people, process, and technology, which we can trust with the security of the cryptography. No, okay, let's move to cryptography. We can park it, and maybe by the 7th or 8th session we'll come back to it. Okay, because this is something not important. You can read about this. This is important. So ring-based protection model of OS, that is ring 0 to ring 3. And what do you need to remember is ring 3 is where your application or user sits. Okay, this is again security context. So either your application or user context is where your R3 is, and this is the lowest possible. So this is where your kernel or firmware will be sitting. So please read about this also. Ring-based protection of OS model. This is something that you need to know. So please note this. I do not have much time to cover cover these things in this session, because cryptography is more important. And then learn about security kernel also. What differentiates security kernel from trusted computing base. Let's proceed to cryptography. Sorry guys, again, I do not have much time, else I would have loved to cover these topics. Skipping to cryptography. Cryptography, basically, there are certain keywords that you need to understand. What cryptography basically means is you have some information, say my name is there, Chandresh and whatnot, my age and whatnot is there in a form. Okay, in a form I filled, there's my name, age, my gender, my date of birth, and I do not wish anybody to be able to understand it. So I'll do something. So I'll do one thing. I'll transform or change or mask the information in such a way that nobody in a legible language be able to read it. For example, the basic reasoning questions that you must have solved is, for example, this is Chandresh ka Chan, and I shift each letter by +1. Okay, so this becomes D, this becomes I, this becomes B, this becomes O. Now Debo doesn't make any sense, or at least it doesn't tell anybody my okay, yeah, sure. We can do that. Just remind me to do it. We'll recap it, please. Yeah, Debo sounds funny. Yeah. So now Chandresh was the real information, but what everyone else will know is Debo, and that is not my real information, so it is camouflage. So now nobody can make as to this is my name. Okay, and whoever is having this function with them, that whenever I shift one letter, I've shifted one letter to come at this, so I'll have to go -1 in order to arrive the name. So to arrive at the actual information, this becomes my key. So this becomes my transformation function. This becomes my key. That is what basically encryption is. You have some information that you want to protect from everybody else, but you want intended recipient to have access to this information. That is encryption, basically. And this becomes your key. +1, -1 is your key. In this case, in this example. Okay. So that is your plain text in that example was Chandresh ka Chan, your plain text. Your ciphertext was Debo. Your key was -1. Okay. Now say somebody is smart enough to understand कि इसने तो ये खेल खेला है कि this guy has shifted every letter by one place. Okay. So now my cipher is weak because everybody now knows it. Ki +1, there's just +1, -1. So I'll introduce IV. IV is what? Initialization vector. So what it is it is just to increase the randomness in the environment. So what initialization say in this case, initialization vector is +2. Okay. So I'll still share the key +1, -1 with my intended recipient who I want to know the information. And we both know that there's a common secret of +2. So now this time around, we'll shift every letter by 3 places. So it will become C, D, E, F. And similarly for all the rest of the letters. And the person who is here also knows that there's a common IV, which we have put. IVs are generally used in block ciphers when there will be multiple, in block ciphers, there are multiple modes and their IV becomes an important factor. So IV is here to increase the randomness in the whole function and make it difficult to understand or guess my key. Okay, that is your IV. Now work factor. Work factor is basically, why is it difficult? Why is it difficult to so you can guess the key, you can guess the cipher also, and you can get back the original data. But why it is not done so often, and why then, and hence encryption protects everything, is because of work factor. So the amount of work which is required to decrypt the encrypted text without knowing anything, sorry, distracted. Sorry. So yeah, work factor basically means that the amount of compute power that you'll require to come from ciphertext to plain text without knowing the key and the cipher maybe is so huge that it becomes impractical. And work factor generally, as somebody has rightly stated, is directly proportional to key length. It is not necessary. It depends on the cipher also, the cipher algorithm that you are using. For example, RSA and ECC are there. You can use a 1024-bit key in RSA, which will take equivalent amount of effort as ECC ka 256-bit. So actually ECC is more efficient, so it will, yeah, 256-bit key of ECC will be as strong as 124-bit RSA. And obviously, since work factor now we have increased, it makes ECC more efficient. So work factor is not always directly proportional to this. Cool. We'll recap anyways. I can extend if you guys can extend. Now, confusion and diffusion. Coming to confusion and diffusion, it basically is a feature of symmetric algorithms. Okay, so these things you'll you'll come across in symmetric algorithm only. What confusion means is it plays a role between the key and your ciphertext. Okay, so changing one bit in the key affects ciphertext at least 50%. Affect 50% of the ciphertext is how a good algorithm should be. So that is what confusion is. The factor by which, if I change the key by one bit, by what factor the ciphertext will be changed is my confusion factor. My diffusion factor is related to plain text and ciphertext. That is, if I change one bit in my plain text, by what factor my ciphertext will change. 50% of my, say if I change one bit in plain text, 50% of my ciphertext changes. So 50% of the bits of the ciphertext changes, then the diffusion factor is very strong. And similarly, if I change one bit in the key, 50% of my ciphertext changes, then my confusion factor is very strong. Now, algorithms can be there can be many cipher algorithms, and it can be either block or stream cipher. So block cipher is basically you fed in a string of information, say 1, 2, 3, 4, 5, 6, 7, 8. Yeah, actually binary mein hoga. It will be in binary in actual when it will be processed by the computer. But say this is your string. Okay. Now I'll make blocks of 8. Okay. 8. Now I'll make blocks of 4 bits each. Okay, I'm considering these all 1 bit each. So in block, I'll make blocks of these bits. In case of block, I define the size of the number of bits on which I'll process the cipher. So say I have a 4-bit block cipher, then it will break down my data into blocks of 4 bits and process 1 block at a time. Okay. So if I have input this 1, 2, 3, 4, 5, 6, 7, 8, and imagine that all of these are 1 bit only, then my block cipher will break it down here and process this separately and this separately. Where does this come on? Sorry, yeah. And the second thing is stream cipher. Stream cipher is, again, you have 1, 2, 3, 4, 5, 6, 7, 8. But in this case, every bit will be processed in real time. So your key is here, your ciphertext is here, your data is here. So key is constantly applied on it and ciphertext is constantly delivered. So this kind of a cipher is used in real-time applications. So say your voice calls and all. So voice calls and maybe real-time video streaming and all. If you're using encryption in such applications which are real-time in nature, then you'll go with stream cipher. And if the time sensitivity is lesser in the application, then you can go with block cipher. So generally, whenever data is at rest, you use block cipher. Whenever data is in motion, you use stream cipher generally. It depends on the, ultimately it depends on the time sensitivity of the application that you're using. Now, what kind of security controls can you achieve using encryption? You can use confidentiality, integrity, authentication, non-repudiation, and access control. I'll tell you everything, okay? So confidentiality, what it is, no unauthorized disclosure must be there. So let's take an example of somebody has told us about asymmetric algorithm where there is a key pair. So there is a public key and a corresponding private key. So in example of confidentiality, maybe let's take an example of RSA cipher in which I get a public key and a private key. Now here's my data. I have encrypted it with my private key, and now asymmetric algorithm mein I cannot decrypt it with the same key that I've used to encrypt it. So I'll have to use my public key to decrypt it. And my public key is already public. So how am I maintaining confidentiality is I've already shared this public key since it is public and it can be shared across internet without fear because it's public knowledge. I can be ensure that, sorry, confidentiality. I can share this with whatever intended recipient that is there. For example, I want to share it with this guy who is there. Say for example, say I'm sharing the information with Amit. So I'll share my my public key with Amit, and I've encrypted this data with my private key. So Amit will be able to decrypt it, but nobody else can. Actually, this is a wrong example of confidentiality. It is incorrect. Sorry, guys. So in confidentiality, I'll use my symmetric algorithm. In symmetric algorithm, you use a single key to encrypt and decrypt both. If I securely share my key with Amit and encrypt the data with my key, I can rest assured that only Amit, who is having this key with which this was encrypted, be able to decrypt it. That is how I'm ensuring my confidentiality. It is only Amit Kaushik and nobody else who can open my encrypted data, because I have shared the key securely with Amit only and nobody else have the access to this key. So that is how we are achieving confidentiality here. How we achieve integrity? For integrity, we go to hash functions. What is a hash function? Hash function is a one-way algorithm. So what it does is it takes any length of data and returns a fixed length of characters. So say you have an imaginary hash algorithm which returns 128 bits as output. So even if you input 1 bit or say 1280 bits, it will always return 128 bits. Chandresh Singh, trainer's full name. Okay. So we use hash functions in order to achieve integrity, because hashes are one-way functions and it is very difficult to gain the information back from a hash. So when we wish to ensure integrity, what we do is we write the message down, we hash it, and we then attach it along with the message itself. And when the other person receives it, they can simply hash it again with the same algorithm and compare the hashes that they have received. If the same hash is there, then the data is unchanged. Hence, integrity is preserved. Now, coming to authentication. In case of authentication, what I'll do is, now let's go to this digital certificates in order to understand authentication. What happens in digital certificate is we go to PKI, which is public key infrastructure. What happens in the public key infrastructure is you have a CA, certifying authority. Okay, that is a trusted root CA. what trusted root CA does is you'll generate a CSR, certificate request basically. A CSR contains some information about you, say your name, the domain name. Let's show you an example of this. Actually, we can show you, I can show you an example of this. So this is a website. This is offensive securities website, and this is their certificate. Okay. That is how a digital certificate looks like. We'll go to details. Here you can see the version number of it. These are all the informations which are stored in a certificate. This is the signature algorithm used. This is the hashing algorithm used. This is the issuer, Starfish Security Limited. Validate. This is the validity information. It is valid till July 2020. The FQDN of the holder of the certificate. Then the public key length is mentioned here. The algorithm is mentioned here, RSA 2048 bit. And you have the public key, which is signed by the issuer. So we have noticed two things here. One is the public key itself. This is the public key. And this is the issuer. Okay. So in this case, this is my CA. The Starfield Secure Certificate Authority G2 is my trusted CA. This is my public key. And this is the rest of the information. For example, offensivesecurity.com and what kind of algorithm is being used. These are the information which are there in the digital certificate. So what happens is you generate a CSR which contains, as I've shown you, which contains your public key and your basic general information around it, and you send it to CA. Now what CA does it? CA attests that information with their private key. And everybody who's accessing your website in their browser or whatever application that they're using to access your website is already having a copy of the public key of the CA. So we all have trusted root certificates installed in our browsers itself. I can show you that also. Just give me a second. Manage certificates. This is what it is looks like. These are trusted root CAs. So these are the trusted root CAs of which this Starfield Root Certificate Authority. This CA certificate is already there. This is CA's public key. This contains CA's public key. Okay. So that is what I'm trying to explain here. This is the trusted root certificate of CA itself. Okay. And this is their public key. And then this is the certificate issued by that CA. So what is happening exactly is, yeah, generally your browser application contains the public key of the root CA, and that is how PKI functions. So in PKI, the root CA, what it does is the CA takes your CSR. CSR is nothing but your public key and your basic information, and it attests that CSR with its public key. And since your browser application is already having, it attests that information with their private key. Okay, private key, because private key shall not come out of this environment. It never leaves this environment, the trusted CA environment, and trusted CA's public key is here already. So what happens is when you try and visit a website, since their digital certificate is there, in which their public key is there, and which is encrypted by CA's private key, my browser uses CA's public key, which is already stored with the browser, to unlock it and gain the certificate of the website. Now, what does this certificate give me? This certificate gives me the website name and information and protocols, etc. Along with that, it gives me the public key of that server to which I'm trying to connect. Okay. Now, what will happen is I have got the public key of the server. Now I can establish the connection with the server, a secured connection with the server. So that is how PKI functions. Okay. If you have any questions, we can discuss it later on. So that is how PKI functions. That is how authentication takes place. That is how you authenticate. Now, non-repudiation. What non-repudiation basically means is, if I sent some data, or if I have published some data, I cannot tomorrow say that, just a second. If I've sent some data to somebody, or I have published some information somewhere, I cannot tomorrow say that it was not published or sent by me. So this responsibility, you cannot get away from the responsibility of having disclosed some information. That is what non-repudiation means. And how do we ensure non-repudiation, and where do we ensure non-repudiation? So we can ensure non-repudiation at two levels. One is at sender side, one at receiver side. And how do we achieve that? We achieve that by means of taking this message, hashing it, and encrypting this hash with my private key. And since this person is already having my public key, once this message and the encrypted hash reaches here, this person will decrypt the hash using my public key, hence ensuring that it was sent by me itself, then running a hash on this message, gaining the hash, running the hash algorithm on this message, gaining the hash, comparing the hash. If the hash matches, that means message was not modified. So A, he has ensured that message's integrity is ensured. B, since it was unlocked by my public key, it is ensured that it was sent by me. So that is non-repudiation of origin here. Now access control, similar to your authentication. Access control basically is very tightly linked with authentication. Access control, generally when we say access control, we mean AAA, authentication, authorization, and auditing. Okay, so access control basically here means this authentication part mostly, and this authentication and authorization part, it deals with that. Now symmetric algorithm, we have already talked about it. If in symmetric algorithm you have a single key and you use that key to encrypt and decrypt both, so you'll have to share the key with whoever you're sharing the data. And in this case, if you're sharing the key insecurely, anybody can unlock the data, and then your encryption doesn't make sense. And that is the challenge with symmetric algorithm. The key sharing is the main problem with the symmetric algorithm, and also the number of participants. As soon as the number of participants grow, your number of key pairs with each one will also grow exponentially. So that is the problem with symmetric algorithm. Basically, scalability and key sharing is the problem with symmetric algorithm. What is asymmetric algorithm? When I encrypt it, I'll generate a key pair every time I wish to encrypt it. So there'll be a public key, there'll be a private key. Okay. Private key will remain with me always, and I'll encrypt the data with it. Public key will be shared with anybody securely because it can be shared. Now, whoever is having my public key can unlock the data who is signed by my private key. So that is how asymmetric algorithm functions. So it solves the problem of key sharing and this scalability. So scalability is linear here because number of keys doesn't increase exponentially. It only needs one key per individual in the network who is trying to communicate securely. Okay. Then you have principles of then you have so I want you guys to read about pretty good privacy. Okay. There's a very good it will be a very good read, and read about Diffie-Hellman. So we have talked about key exchange and encryption in asymmetric. There is a middle ground here, which is Diffie-Hellman. Diffie-Hellman is only used for key exchange and not encryption. Okay, so read about Diffie-Hellman and this PGP, pretty good privacy. I'm sure that you'll like it. What is digital signature? Digital signature is basically hashing the message and then signing it with your public key, with your private key. So that is your digital signature. Okay.